to another professional prep video. So in this video, I have part 1 of finding antiderivatives. So I have a few examples that we're going to do in this video, and I think you'll find these examples rather simple after some explanation and maybe doing one or two of them. In our next video, we'll have some harder examples, but we haven't formally introduced this symbol, but this is an integral sign. And basically, integral is just the opposite of derivatives. So, sort of like how multiplication and division undo each other, derivatives and integrals undo each other. And those are the two major operations of this course. So, what you're going to see in this video is how to find the antiderivative of certain problems, such as this one. So let's get started. So we know that the antiderivative, we know how to take the derivative. So let's try thinking about how to go the other way. So the antiderivative or integral of 3x squared, and you can ignore this dx. That's the operand for this integration operation, but you don't have to worry. You don't have to worry too much about that. So antiderivative of 3x squared. Well, let's do some reverse power rule here. In order to do reverse power rule, we add 1 to the exponent, so 2 plus 1 is 3, and divide the coefficient by that number that we got. So 3 divided by 3 is 1, and then the exponent is a 3 because 2 plus 1 is 3, so we get x cubed, and we can easily check our work by finding the derivative of x cubed. And sure enough, the derivative of x cubed is going to be 3x squared. And this is the part that sometimes is easy to forget, but you need to do plus c. And c can just be any constant. But let me ask you this. What is the derivative of x cubed plus 7? It's going to be 3x squared, because that plus 7 just turns into a 0, since the derivative of any constant is 0. So that's why you have to include this plus c. We need other information in order to solve for this c. So right now we just need to put a plus c at the end of each of these. Next example, secant squared x dx. Antiderivative of secant squared, tangent. Tangent x, and then this is a good habit to get into, putting the plus c at the end, because we are going to need this. Next problem ties together some addition rule. Secant x tangent x plus 4x cubed. Secant x tangent x. What's the antiderivative of that? Well, this should sound familiar because the derivative of secant x is secant x tangent x. So secant x. Now we've got some reverse power rule. 3 plus 1, 4. 4 divided by 4, 1. So that's going to be secant x plus x to the 4th plus c. And then our last example here is sort of a tricky one, and that involves some chain rule, but we can definitely work through it. Integral of 3e to the 3x dx. So for chain rule, we know that you have to distribute the derivative of the power, the exponent, to the front because of the e, the exponential. So how would we end up with a 3 out here? Well, we'd need to multiply by 3. So in other words, this exponent, the derivative of the exponent would have to be 3. And you'll notice that 3x has a derivative of 3. So this is actually just going to be e to the 3x plus c. And this usually works for all functions involving e. For example, e to the 4x. Derivative of that is 4e to the 4x. That's usually a truth that holds true for these, and that can really help. And to check this, derivative of e to the 3x, e to the 3x itself times the derivative of this, 3 3e to the 3x, and then our plus c from before obviously carries over. So that's all I have for you for this video. Those were some simpler examples just to get everyone introduced to the integration sign symbol, how to deal with that, and antiderivatives. In future videos, this was part 1. In future videos of finding antiderivatives, we'll be dealing with much more complex things under the integral sign, and we will learn about what's called U substitution. So there's something to look forward to, I guess. But that's all I have for you for this video. Have a great day, everyone. Thank you.